Hi class, we have arrived to section 5.7, inverses and radical functions. So verifying two functions are inverses of one another. So remember, that's just us checking that if we have f and g, that we take f composed with g of x, and that equals g composed of f of x. But both of those equal x, and that's exactly what this is saying here. So we know that they're inverses if we compose them and we get x out of both of them. So let's show on this example that f of x and f inverse are in fact inverses of each other. So, and this is for x not equal to 0 or -1, so we're excluding that. So we want to make sure that we can demonstrate then that f composed with f inverse of x is equal to x. But similarly, we also want to show that f inverse composed with f of x is also x. Okay. All right, so let's go ahead and compose this. So let's take, here's our f of x. And so we're going to go ahead and plug in f inverse, which is 1 over x minus 1. So when we plug this in, we're going to get 1 over x minus 1 plus 1. Well, here our 1's, right, we can drop the parentheses, our 1's ends up canceling out, so we end up with 1 over x. Now this is a complex fraction, and so this really becomes, this is the same thing as saying, looking at 1 divided by 1 over x, which is the same as 1 times, right, because we'll change that 1 over, so then this does equal x. Alright, so now let's take a look at the other way around. Okay, when we look at it the other way around, we're going to take f inverse, and we're going to plug in f of x, which is 1 over x plus 1. And so when we do that, we end up with 1 over x plus 1 minus 1. Alright, so this right here, this is a complex fraction again, so this is the same thing as saying 1 divided by 1 over x plus 1. And if you don't remember this, one way we can do this is that this is the same thing as keep, change, flip. So kind of like KFC, but keep, change, flip. So we're going to keep that 1, we're going to change that division to a multiplication, and then we're going to flip this to x plus 1. Okay, I'm just going to tackle in that minus 1, so just bringing this guy down. And so now, this is just 1 times this, so then I'm just left with x plus 1 minus 1, and so my plus 1 and my minus 1 kind of go away, and I'm left with x. And so it checks out. I've checked both of them, so it turns out that they both are inverses. Okay. All right, let's take a look. So recall that in order for us to find an inverse, right, so these were our steps to find an inverse. We're going to replace f of x with y, swap the x and y, we're going to solve for y, and then we're going to replace that y with the correct inverse notation here. So let's take a look at how we would find the inverse to this polynomial function. So the first thing we want to do, okay, is we're going to replace f of x with y, so we'll have y equals 5x cubed plus 1. And then we're going to swap our x's and our y's. So we're going to get x equals 5, and now I'm going to have y cubed here. Alright, so I swapped my x and my y, and now we want to go ahead and we want to solve for y here. So we want to get everything, we want to basically isolate y. So let's go ahead and move x, that plus 1 over, so I have x minus 1 equals 5y cubed. So now I'm going to divide both sides, whoops, that was weird, both sides by 5, divide by 5, and then I have y cubed, x minus 1 over 5. So how do I get rid of that cubic root? I need to take the third root of that, so I can raise that to the 1/3. Or I could take the third root, so this is the same thing as taking y to the third and taking the third root of that. So these are the same thing. So when I raise it to the 1/3, notice that those exponents kind of go away, and so I'm left with y equals x minus 1 over 5 to the 1/3 power, right? And so now we're going to replace that with f inverse of x notation. So I have x minus 1 over 5 to the 1/3. And this is going to be our inverse. All right, let's look at the next one. So restricting the domain. So if a function is not one-to-one, it cannot have an inverse. And we saw this with, remember when we were checking our parabolas, for instance, right? It fails that horizontal line test. So the moment it fails that horizontal line test, it cannot have an inverse. So it's one of the requirements for an inverse. So if we restrict the domain of the function so that it becomes a one-to-one function, this creates a new function, and this new function can have excuse me, can have an inverse. So hold on. Sorry about that. All right, so let's find the inverse of the function f of x, x minus 4, quantity squared, for x is greater than or equal to 4. So what is the domain of the inverse? So if our original, let's break this up. So our original function is f of x is equal to x minus 4, quantity squared. Notice that we are restricting it for x is greater than or equal to 4. So our domain here is going to be x is greater than or equal to 4. So we're going to write that as 4 to infinity. So what I want to pause real quick and look at this graphically. So from a graphical perspective, right, we're looking at the graph. We have a shift here. Actually, we're looking at the first quadrant. Here's our parabola. And so what's happening with the domain of 4 is that we're basically slicing this parabola, and we are only considering this side over here that is part of the domain. The other side, we are ignoring it. And so that's what's happening here when we restrict the domain. So our domain is 4 to infinity. So what's our range? Well, our range is going to go from 0 to infinity. Okay. So now let's figure out, okay, well now can we calculate the inverse, right? And so to calculate our inverse, first thing we're going to do is we're going to swap that f of x for a y. So we're going to have y equals x minus 4 quantity squared. Now we're going to swap our x and y's. So we're going to get x equals y minus 4 quantity squared. And now we're going to go about solving this. So we're going to take the square root of both sides. So here I would normally end up with plus or minus x equals y minus 4, right? Because I've taken the square roots. I'm basically taking the square root of both sides. But this is the main reason why we end up with not having an inverse, because we end up with two functions. But since we have restricted the domain and we're only looking at half of the parabola, we are no longer considering the negative side. We're looking at the positive side. So that's why we end up with only one value. So now we're going to go ahead and add 4. So we're going to end up with the square root of x plus 4 is equal to y. So therefore the square root of x plus 4 is equal to the inverse function. And so this is going to be our inverse. All right. So what is the domain of the inverse? Okay, so our domain here, so remember that when we have our original function f of x, for the inverse they get swapped. So the inverse function, so f inverse of x, will have a domain that is the same as the range. So it's going to go from 0 to infinity. And then the range is going to be the original domain. So that's going to be 4 to infinity. Okay. And that's it. So remember, they end up getting switched for the inverse function. All right, go ahead, pause this video, try this example. All right, so after pausing the video and attempting the problem, is this what you got? So here we have our inverse function as the square root of x plus 3, entire function plus 2, and then notice that the domain and the range, they swap, right? So we go from -3 to infinity to, and then their range is from -infinity to 2. All right? All right. All right, our next one, find the inverse function of f of x, x minus 4. We're restricting it to x is greater than or equal to 4. What is the domain of the inverse? So let's go ahead and try this one out. So if our function is x minus 4, our domain here is going to be x is greater than or equal to 4. So we're going to go from 4 to infinity. Our range here, so the way that we calculate our range for this one, we're going to go ahead and plug it in. So we plug in 4, which is the lowest value in our domain, into the function. So notice 4 minus 4, we get 0. And so that means that our range is going to go from 0 to infinity. Okay, and so again, the way we calculate that range is we plug in 4 into the function. All right, let's go ahead and calculate the inverse. So the inverse, we're going to have y equals x minus 4. Let's switch those variables. We end up with x squared equals y minus 4. We're going to add 4 to both sides and get y. So then our f inverse function is equal to x squared plus 4. So what's the domain? So for our f inverse, again, we're going to swap those two. So our domain is going to go from 0 to infinity, and our range will go from 4 to infinity. Okay. That's it for that one. All right, let's take a look at this. So a mound of gravel in the shape of a cone with a height equal to twice its radius. The volume of the cone in terms of the radius is given by this function here. Find the inverse if the function that determines the volume of v of the cone and is a function of radius r. Find the inverse if the function that determines the volume v of a cone and is a function of the radius r. Sounds a little funny. Then use the inverse to calculate the radius of such a mound of gravel measuring 100 cubic feet. Use pi is equal to 3.14. All right, let's go ahead and find the inverse. So we have our v is equal to 2/3 pi r cubed, right? So the way we're going to find the inverse is we're really going to solve for r. So let's go ahead and start solving this for r. So the first thing we're going to get rid of is the 2/3, so let's multiply by the reciprocal. So we'll multiply by 3 over 2v. So if I multiply this by 3 over 2, we'll see that that cancels out. So we're left with pi r cubed. We're going to go ahead and divide by pi. And divide this by pi. So this becomes 3v in the top, and I end up with 2 pi on the bottom, and this is equal to r cubed. Okay. So one way to see this way, let me pause for a second, is if I have v equals 2/3 pi r cubed, I could multiply this side, both sides by 3, and so I end up with 3v is equal to 2 pi r cubed. And then you can see that I can divide by 2 pi to get rid of the 2 pi. So this is one way that you can see how I got that 3v over 2 pi in case this step to this step confuses you. I just wanted to make sure that that was clear. Okay, so now we're left with r cubed. So in order for us to undo the r cubed, we need to take the third root from both sides. So we're left with r equals the third root of 3v over 2 pi. Okay, so this would be the inverse. Okay, so this is this function is the inverse of the formula for v in terms of r. Okay, so that's what we are seeing here. So now we want to use this to calculate the radius of such a mound of gravel measuring 100 cubic feet. So 100 cubic feet, that's going to be our volume. So let's go ahead and plug that in. So we're going to get r is equal to the third root of 3 times 100 cubic feet over 2 pi. So let's go ahead and plug that into our calculators. All right, and I got 3.627, and because we're talking about cubic feet in volume, so this would be a radius of 3.627 feet. Okay. All right, so let's take a look. Oh, that's the end of 5.7.